Alright, this video is about special right triangles and trigonometry on the unit circle. Okay, to start off, I want to review the patterns that you learned back in geometry days of your 45, 45, 90 triangles. Okay, your 45, 45, 90 means it's isosceles right triangle, and the two side lengths are the same. And the pattern is, if the two sides are the same, then the hypotenuse is always that value times the square root of 2. So I always made a little box. X squared root of 2, okay? And I had my students make this box, and then if you're given something simple where they give you the side length, let's say a 5, you know that's across from a 45 angle. That means this side has to be a 5, and then the hypotenuse has to be 5 square roots of 2. It's that simple. If you know the legs, it's really easy. So what if they throw you a curveball? What if they give you only the hypotenuse, the one with the radical in there? So let me show you the trick to that. So let's just say I get this triangle right here, and it's isosceles right, I can see that, but all they tell me is that the hypotenuse is 12. So I have to use my table, and I know that the 12 is across from the 90, so it goes below the 90 here. I need to do something to calculate what is x. There's many ways you could go about it, but here's the rules I use. Number one, you divide that value by 2. Why is it a 2? Because 2 is under the radical. Divide by 2. Then you take it, what you get, and you multiply by the square root of 2. Alright, so if I divide by 12 by 2, I get a 6, right? Then I multiply it by 6 by square root of 2, and I get 6 square root of 2. Well, these two legs are the same, so there's my solution. I know all three sides now. Alright, 30, 60, 90 is this tall, skinny triangle. 30 is the smallest angle, and 90 is the big one, you know that. And the pattern for this one is 30, 60, 90, x square roots of 3, and a 2x. Alright? Now, the side across from the 30 is x. Across from the 60, x square roots of 3. Across from the 90 is your 2x. Now, obviously, if they tell you x, then you can quickly find the other two sides. If they tell you the hypotenuse, which is 2 times x, all you have to do is divide it by 2, and then you know x, and you can plug it in to find the third side. So the stinker comes when they give you the side opposite the 60-degree angle, and that's it. Let's say they give me this, and I need to find the other two sides. So following my pattern, alright, so all I know is the 9, and it's across from the 60, so I'm going to put it here. Okay, like we did before, notice that this is the one with the radical in it, so I've got to solve it for x. Okay, similar 2 steps as we did before. First, this time we're going to divide by a 3. Why a 3? Because the 3 is under the radical. Then I'm going to multiply by a radical 3. Okay, so if I divide by 3, I get 3. Multiply by a radical 3, I get square root of 3. So that means the side opposite the 30-degree angle is 3 square root of 3. Now to find the side opposite the 90, all I do is multiply this by 2. So I get 6 square root of 3. So my hypotenuse is 6 times the square root of 3. Okay, so it's a pretty simple pattern. The only sticking point is when they give you the side with the radical, but if you follow these steps, you can find them. Alright, so let's try one of these. This trig, look, we're going to find all the trig functions where the angle is 30 degrees, where theta is 30 degrees. So this is my 30-degree angle. That makes this my 60-degree angle, and this is my 90-degree angle. Alright, now we are on the unit circle, so imagine this is the unit circle, and this is my radius right here. Okay, this is the radius of the unit circle. And we always said the radius is always 1. So the side opposite that 60-degree angle is a 1. So if I go 30, 60, and 90, okay, the pattern was x square roots of 3, and 2x. Sorry, that's messy. Alright, so what I do know is that the side opposite that 60-degree angle is a 1. So I'm going to put a 1 right here. Now, in order to find my other two sides, I need to do a little math. Anytime you're going from the radical step to the non-radical step, on this one, here's what you're going to do. You're going to multiply, you're going to divide by, and then multiply by a radical 3. So if I divide the 1 by 3, I get 1 over 3. Multiply it by the radical 3, I get square root of 3 over 3. So then the side opposite the 30-degree angle is square root of 3 over 3. Then, now that I know this, now I know what x is, I multiply it by 2 to go over here. So I get 2 square roots of 3 over 3. So that's my hypotenuse, 2 square roots of 3 over 3. All right? So to catch this again, since I came from the middle with the radical in there, to get rid of that radical and go back to just x, I divide by 3, because there's a 3 under the radical, then I multiply by the square root of 3. That's the pattern you're always going to follow if it's a 30, 60, 90. So now that I know my three sides, now I can do my sine. Remember, sine is opposite over hypotenuse. So my opposite side is square root of 3 over 3 over the hypotenuse. Well, that's 2 square roots of 3 over 3. Okay, this is good practice on keep it, change it, flip it. All right, so I'm going to keep the top, change it to multiplication, and flip the bottom. All right, now when I multiply straight across, notice some similarities. I can cancel this 3 with this one, this square root of 3 with this one. Well, what's left on top is not a 0, it is a 1. So my answer is 1/2. My sine then is 1/2. All right, cosine says adjacent side over hypotenuse. So my adjacent side is a 1 over hypotenuse of 2 square roots of 3 over 3. Okay, keep it, change it, flip it. All right, well, that gives me 3 over 2 radical 3. I have to rationalize that. So I get 3 square roots of 3 over, that's going to be 2 times 3, or 6. So that reduces to 2. So then my cosine is the square root of 3 over 2. And lastly is my tangent. Remember, that's opposite over adjacent. So the opposite side is square root of 3 over 3 over adjacent, which is a 1. So thankfully, that one's pretty easy to solve. But you can see, by knowing just that unit circle's radius, I can find the three sides of this triangle. All right, let's try this again with our angle theta is 60 degrees. That means this one's 90. And again, our radius is right here. I'm sorry, this one's 30. The radius is right here, so this side is a length of 1. To 60, this is my adjacent, opposite, hypotenuse. All right, so to find all these trig functions, I need the three side lengths. All right, so in order to do that, I need to follow my pattern. 30, 60, 90, x, x square roots of 3, and 2x. All right, and in this situation, what do I know? I know the side opposite the 30-degree angle. So this picture is definitely not to scale. Side opposite the 30-degree angle is a 1. So I'm going to put a 1 right here. That means the side opposite the 60 is 1 square root of 3. Opposite the 90 is a 2. So this is a 2, and this is the square root of 3. So the picture's not to scale, but you see how I solved for the three sides. All right, so to find the sine of 60 degrees, remember that's opposite over hypotenuse. Opposite the 60 is the square root of 3. Hypotenuse is a 2. No radicals in the bottom, I'm good. Cosine, adjacent over hypotenuse. Well, the adjacent side is a 1, hypotenuse is a 2, no big deal there. Tangent is opposite over adjacent. Opposite is square root of 3 over 1, so it's just the square root of 3. So at 60-degree angles, these sides are pretty easy. 30-degree angles are a little more tricky. All right, so what happens in this example is it's going to give you two of the trig functions. You've got to find the other ones. Okay, so I'm going to draw a random right triangle. Okay, it's not that pretty, but there you go. And I'm going to put in a 60-degree angle. I know that sine is opposite over hypotenuse, so I know opposite the 60 is square root of 3. Hypotenuse is 2. Cosine is adjacent over hypotenuse, so this is a 1. Now I know my three sides. I can calculate the rest of these. Tangent is opposite over adjacent, so opposite would be square root of 3 over 1, which is square root of 3. Cosecant, remember, is the reciprocal of sine, so it's hypotenuse over opposite. So in this case, it's 2 over square root of 3, which means I have to rationalize. So I get 2 square roots of 3 over 3. Secant is the reciprocal of cosine, so that's a hypotenuse over adjacent. So then a hypotenuse is a 2, adjacent is a 1, So that means my secant is a 2. Get my answers here very clearly boxed. And then cotangent. Okay, well, we just said that tangent over here is square root of 3 over 1. That's the cotangent's the reciprocal, so it's 1 over the square root of 3, which requires rationalizing. So I get square root of 3 over 3. All right, now I've found all 6 trig functions. All right, then the last type of problem you're going to have are some proving problems, where you just prove the relationships between these trig functions. Now, if you recall, once upon a time, we told you that sine of theta is equal to opposite over hypotenuse. And then we talked about cosecant of theta is hypotenuse over opposite. So they are reciprocals of one another. Okay? So what that means is, since cosecant is the reciprocal of sine, you can see it here, you can also write it like this. So since sine is the opposite of cosecant, it can be written as 1 over cosecant. They're reciprocals of one another. So just think of it that way. So this proving problem, and it works like this for cosine and secant, cotangent and tangent, the relationships are the same. Okay, so keep this in mind, the reciprocal relationships. So I need to prove that the sine of theta times the cosecant of theta is equal to 1. So the goal you want to make is to get these in the same terms. Okay, so sine is more familiar, so I'm going to leave sine as sine. And I want to put cosecant in terms of sine. So we just said cosecant is 1 over the sine. So I'm going to do 1 over the sine. And when I multiply those, what do you get? You get the sine of theta over the sine of theta, which is 1. And that is my proof that these two things are really multiplied are 1. Don't panic. Practice this. Use the properties and relationships you know. You can do this. All right, for the whisk, this is like example 3. Okay, I'm going to give you, it's a tangent of 30 degrees and the secant of 30 degrees. And I want you to use these values to help you find the cosecant of 30 degrees. Use your notes, use the relationships, and I will see you in class.